Hello my friends and welcome back to the You Can Do TV channel. Tech Infra's weed harvester machine is actively deployed for aquatic weed removal at Bellendore Lake, offering a mechanized and eco-friendly solution to control excessive plant growth. Resembling an underwater lawnmower, the harvester cuts, collects, and stores submerged, emergent, and floating weeds using a 3-conveyor system. Equipped with horizontal and vertical cutter bars and a submersible pickup conveyor, it efficiently severs vegetation as it moves forward. Once full, the onboard storage, ranging from 3 to 30 cubic meters, allows for shoreline unloading. With a production rate of 15 to 20 loads per shift, this made-in-India system has proven reliable, with nearly 40 units delivered to Indian government bodies. Customization is available based on lake size, weed type, removal percentage, and urgency, ensuring optimal performance. This technology enables sustainable restoration of water bodies like Bellendore Lake, while minimizing manual labor and environmental disruption. During a significant flood event on one of the world's most polluted rivers, the Interceptor trash fence, an experimental passive barrier system designed by the Ocean Cleanup, was subjected to extreme hydraulic forces. The structure consists of anchored vertical poles supporting a reinforced mesh barrier across a key choke point in the river. Its function is to intercept and retain buoyant plastic debris driven by strong currents during peak flow events. During the flood, 2 of the structural poles experienced tilting due to lateral force overload from a dense accumulation of debris and high-velocity water pressure. Erosion at the anchoring points further destabilized the ground interface, allowing a substantial volume of plastic waste to breach the system and continue downstream.
I cannot believe this.
Because the heavy force that follows the trash and the force of the river.
Despite the partial structural failure, the trash fence successfully captured a large quantity of waste, confirming its fundamental design viability. As this deployment was a pilot phase, the incident revealed critical weak points in structural resilience and soil retention that require immediate engineering refinement. The event provided actionable data for reinforcing ground anchorage, redistributing load tension, and enhancing containment under high-flow conditions.
No, and I hope that for the next flash flood,
Lessons learned will inform subsequent design iterations to ensure the system's readiness for future flash floods and improve its effectiveness in preventing marine plastic leakage.
We know for sure that all of this amount of plastic will out of the ocean.
Each year, Glencore's Horn Smelter and CCR refinery collectively process approximately 100,000 tons of secondary raw materials, including electronic waste, lithium-ion batteries, industrial scrap, and end-of-life components. The recycling process begins with the classification and sampling of incoming materials to determine metal content and optimize downstream recovery. Materials are then shredded into smaller particles to facilitate uniform melting and increase surface area for metallurgy. At the Horn Smelter, shredded feedstock undergoes pyrometallurgical treatment in 4-stage furnaces operating at around 1,200 degrees Celsius. During smelting, base and precious metals, primarily copper, gold, silver, platinum, and palladium, are separated from non-metallic residues. The resulting matte is enriched in copper, ranging from 25% to 98% purity across stages. Once optimal concentration is achieved, copper is cast into anodes weighing approximately 300 kilograms. These anodes are transferred to the CCR refinery in Montreal, where electro-refining is performed. In electrolytic cells, electrical current drives metal ions from the anode to the cathode, producing high-purity copper at 99.99% grade. Precious metals and other byproducts settle as anode slimes, which are further processed for. This integrated recycling workflow supports a circular economy by extending material lifespans, reducing reliance on primary mining, and diverting waste from landfills. Additionally, Glencore's infrastructure accommodates increasing volumes of production scrap from emerging sectors such as electric vehicles and renewable energy. The technical configuration of smelting and refining assets, combined with decades of metallurgical expertise, enables efficient recovery of critical metals essential for the global energy. The Ocean Cleanup, in partnership with Clean Harbors Jamaica and the Grace Kennedy Foundation, executed the deployment of Interceptor 015 in Kingston's Sandy Gully in November 2024. Sandy Gully is the principal drainage conduit within Kingston, receiving inflows from multiple tributaries and discharging directly into Kingston Harbor. The gully functions as a major pathway for stormwater runoff, transporting approximately 1,000 metric tons of solid waste annually, including plastics, sediments, and organic matter, which adversely affect marine ecosystems and local fisheries. The installation procedure commenced with the precise placement of 2 anchor plates, each engineered to withstand a holding capacity of 100 metric tons. The anchors were lowered into pre-excavated trenches and oriented at calculated angles to optimize load distribution and hydrodynamic stability. Ground ballast was applied atop the anchors to secure their position against flow-induced forces. Chains connected the anchors to a modular floating boom system. The boom system consists of 44 segments, each measuring 6 meters in length and weighing over 100 kilograms. Structural reinforcements include upgraded connection points and stiffeners designed to maintain the integrity of the barrier under fluctuating hydraulic pressures. A flexible rubber sheet seals the joints between segments to prevent debris bypass and improve containment efficiency. Community engagement was incorporated throughout the project phases. Input from local residents, with decades of experiential knowledge, informed the hydrological and sediment transport characteristics of the gully. Traditional site blessing ceremonies were conducted in accordance with local customs to promote project acceptance and foster community ownership. Following deployment, monitoring revealed effective debris interception during rainfall events, with significant volumes of plastic waste and bulky items, such as refrigerators captured by the barrier. Data acquisition and operational monitoring are ongoing to assess performance, optimize maintenance schedules, and adapt to seasonal flow variations. This project establishes a replicable model for urban waterway pollution mitigation through integrated engineering solutions, combined with community involvement. Expansion plans include additional interceptor installations targeting key drainage systems throughout Kingston to significantly reduce plastic pollution and improve water quality metrics over the long term. During its first major storm event, Interceptor 007, the Ocean Cleanup's autonomous waste collection system, was deployed at Ballona Creek to capture floating debris before it reached the Pacific Ocean. The system utilizes a V-shaped barrier composed of floating booms strategically positioned to funnel trash toward the central intake module. As waterborne debris accumulates at the apex of the V, it is directed onto a conveyor belt system powered by solar energy and flow sensors, which lifts the material and deposits it into onboard dumpsters located on a floating barge. One operational challenge observed was leakage through gaps between the boom and the levee wall, as water levels rose and fell with the tide. The engineering team resolved this by repurposing upstream containment booms to extend the barrier and seal the lateral openings. The modified configuration increased containment efficiency and redirected additional debris toward the intake zone. Once full, each dumpster, capable of holding up to 12,000 pounds of waste, is hoisted off the platform by crane and replaced with an empty unit, enabling uninterrupted operation. The collected waste is then transported to local facilities for sorting, compression, and processing. The system functions autonomously, requiring no onboard crew, and is capable of continuous operation under variable weather conditions. Interceptor 007 successfully intercepted approximately 35,000 pounds of waste during this first event, demonstrating both its collection capacity and operational reliability. Public and municipal feedback confirmed visible improvements in downstream beach cleanliness, validating the system as a scalable solution for urban waterway plastic interception ahead of ocean discharge. The Dulevo Mix series consists of mechanical street sweepers with integrated vacuum systems, developed to meet diverse cleaning requirements across urban and industrial environments. The series includes models from 2000 to 6000, each engineered with specific features to optimize performance, dust control, and operational efficiency. The Dulevo Mix 2000 is a compact model designed for narrow urban areas, pedestrian zones, and confined spaces. It features a mechanical sweeping system with a main brush and two independent side brushes, combined with a moderate capacity vacuum system. The machine is equipped with a high-performance Gore dust filter, enabling effective, fine particulate capture while minimizing environmental emissions. Its compact size and hydraulic controls provide excellent maneuverability and ease of maintenance, ideal for tight city streets and sidewalks. The Dulevo Mix 3000 offers increased sweeping width and hopper capacity, making it suitable for medium-sized urban environments such as parking lots and public spaces. It incorporates an improved filtration system and an electronic control interface that optimizes sweeping efficiency and reduces operational costs. Full hydraulic drive and a spacious operator cabin enhance comfort and allow for extended continuous operation with high reliability. The model's modular design facilitates rapid serviceability and parts replacement. The Dulevo Mix 5000 is tailored for industrial applications, including factories, ports, and material yards. It features a large debris hopper of up to 5 cubic meters and abrasion-resistant brushes designed for heavy-duty cleaning tasks. The machine uses a multi-stage dust filtration system that effectively captures fine dust particles while maintaining stable operation under harsh conditions. The operator cabin is equipped with climate control and vibration damping to improve comfort during long shifts, ensuring operator safety and productivity. The flagship Delevo Mix 6000 model targets large-scale cleaning projects such as metropolitan areas and extensive industrial zones. It integrates advanced gore filtration technology, a fuel-efficient engine, and an optimized mechanical sweeping system. The machine offers wide sweeping coverage and smooth operation, supported by automated control systems and remote performance monitoring capabilities. This model complies with stringent environmental standards and provides a comprehensive solution for high-demand cleaning scenarios. Enhanced diagnostics and telematics features allow fleet managers to optimize maintenance schedules and operational uptime. In summary, the Dually Mix series provides a versatile range of street sweepers designed for various operational scales, ensuring effective cleaning performance combined with environmental compliance and operator comfort. The process begins by preparing the materials in the specified ratio: 10% shredded styrofoam, 40% shredded plastics, and 50% used cooking oil. First, load the used cooking oil into the melting chamber and heat it until it reaches the boiling point of approximately 100 degrees Celsius. Once the oil is heated, activate the stirrer to ensure an even temperature distribution. Next, add the shredded plastics and styrofoam into the chamber and continue stirring while maintaining the temperature. Allow the mixture to melt completely over the course of 1 hour. After melting, drain the excess oil carefully until the molten plastic flows freely. Pour the melted plastic into molds and allow the molded bricks to dry for at least 3 hours before further processing or use. The lithium-ion battery recycling process begins with sorting and preparing various types of spent battery materials, including used cylindrical lithium batteries, soft-pack battery materials, and battery leftovers. The recycling plant first disassembles the batteries to separate the casing, electronic components, and active materials. Next, the battery cells undergo safe crushing and shredding to release valuable metals such as lithium, cobalt, nickel, and manganese. These materials are then processed through chemical and mechanical separation methods to purify and recover reusable elements. The recovered metals are refined and prepared for reuse in new battery production. Reducing environmental impact and supporting sustainable resource management. Proper safety protocols are followed throughout to handle hazardous substances. China's river cleaning robot is a smart, flexible innovation that collects floating waste from various water bodies, supporting environmental protection alongside PKU Pioneer's advanced oxygen generation tech for efficient wastewater treatment and reduced emissions. For the cleaning and desilting of Bhopal's lakes, an amphibious excavator is deployed, designed for soft terrains and water bodies. Its extendable track-mounted pontoons enable flotation and mobility, while a 50-foot reach arm ensures efficient dredging of wide areas. 2 hydraulically operated 6-meter spuds anchor the machine to prevent drift during operation. Retractable pontoons allow for easier land transport and improve stability in water. The machine operates in heavily silted swamps formed by years of sewer discharge, effectively restoring aquatic capacity and flow. Complete drain clearance involves the thorough removal of obstructions, sediment, sludge, and debris from drainage systems to restore optimal flow and prevent blockages or flooding. This process typically begins with an inspection using CCTV drain cameras to assess the condition and locate any obstructions within the network. Once identified, high-pressure water jetting is employed to dislodge and flush out accumulated materials from the pipeline walls. In cases involving heavy or solidified debris, mechanical rotting or vacuum suction units may be used for extraction. For large-diameter drains, culverts, or stormwater channels, specialized equipment such as combination jetting and suction units or robotic cutting tools may be deployed. These tools allow for precise removal of root intrusions, grease buildup, and mineral scale, without damaging the integrity of the pipe. Following debris removal, a final CCTV survey is often conducted to verify the cleanliness and structural condition of the system. In flood-prone or industrial areas such as railways, regular full sewer cleaning is essential to maintain system capacity and avoid operational disruptions. Environmental and safety regulations are strictly followed, with collected waste transported to licensed disposal facilities. Additionally, preventative maintenance schedules and real-time monitoring systems are recommended to minimize emergency interventions and extend the operational life of drainage infrastructure. Overall, complete drain clearance is a critical part of urban infrastructure management, ensuring reliable drainage performance and environmental protection across municipal, commercial, and industrial applications. The construction and demolition (C&D) waste sorting system is a comprehensive, multi-stage process designed to recover valuable materials and minimize landfill disposal. It begins with inbound material fed into a shredder, where bulky construction waste is size reduced into more manageable fragments. The shredded material is then transported to the presort area, where long parts such as pipes and rebar are manually or mechanically removed. In this stage, trash, metal, large wood, and mixed rock are separated from the stream. The remaining material proceeds to the C&D screen, which performs an 18-inch cut, splitting the flow into overs and unders. The overs, larger than 18 inches, are sent for further separation, where materials like OCC, old corrugated containers, and wood are recovered. The unders, smaller particles, move to a 3-inch fine screen, isolating finer materials for further classification. Material passing through the fine screen enters a double wall air separator, which divides it into heavy and light fractions based on density. The heavies are processed through a cross-belt magnet that extracts ferrous metals, resulting in a clean final heavies product. Meanwhile, Tamra optical sorters target the medium fraction, ejecting wood and enhancing material purity. The light fraction from the wall air typically consists of plastics, insulation, and residual light debris. A secondary cross-belt magnet on fines captures remaining metal fragments, while a 1/2-inch fine screen isolates ultrafine particulate matter. This advanced system maximizes resource recovery, reduces environmental impact, and supports the circular economy by reclaiming recyclables from complex C and D waste streams through mechanical, magnetic, and optical separation technologies. High-pressure culvert jetting is an efficient method for cleaning blocked or silted culverts, using pressurized water to remove debris, sediment, and organic buildup. The system employs specialized nozzles that deliver powerful water jets capable of dislodging stubborn materials along the culvert's interior. A key feature of this operation is the use of recycled water, reducing environmental impact and water consumption. The process restores full flow capacity, prevents flooding, and supports long-term infrastructure performance. Culvert jetting is ideal for stormwater systems, railways, and road drainage networks, where regular maintenance is critical for operational safety and efficiency. The Edmonton Integrated Processing and Transfer Facility, IPTF, part of the Edmonton Waste Management Center, handles the city's residential organic waste through a large-scale composting operation. Approximately 50% of residential waste, comprising food scraps, yard waste, non-recyclable paper, and disposable diapers, is processed to recover valuable organic material. At the IPTF, waste is tipped onto a concrete floor where front-end loaders and hydraulic grapplers move it into piles. Oversized or non-compostable items, such as metals, furniture, carpets, and hazardous materials like propane tanks, are manually extracted for safe disposal. The remaining stream is transferred via conveyor belts to a mechanical and manual sorting line. Organic fractions like grass clippings and leaves are directed toward composting, while inorganics and recyclables are diverted. Trommel screens, consisting of rotating drums with calibrated perforations, separate fine organics from bulky contaminants. Ferrous metals are recovered through overbelt magnetic separators. The screened organics are conveyed to the compost facility, where they are mixed with biosolids in industrial-scale mixers or rotating tubes, approximately the length of a hockey rink. These mixers homogenize input materials and initiate aerobic decomposition over a 2-day resi. Following this, the partially decomposed material undergoes secondary screening and metal recovery before entering aerated static piles within the composting hall. Auger systems ensure continuous turning, aeration, and moisture control. After 1 month, the material is transferred to outdoor curing pads for a 5 to 6 month maturation phase. Final screening removes residual inert materials, producing a stabilized, high-quality compost suitable for agricultural and horticultural use. The system maximizes organic waste recovery, reduces landfill, The fully automatic car washing machine in Ahmedabad offers a high-efficiency, contactless vehicle cleaning solution designed for both commercial and high-volume use. Equipped with precision-controlled robotic arms, the system performs a complete wash cycle, including pre-wash, foam spray, scrubbing, high-pressure rinse, and drying without manual intervention. Integrated sensors scan vehicle dimensions to adjust nozzle positioning and brush contact, ensuring uniform coverage and surface safety. The machine utilizes a closed-loop water recycling system that filters and reuses water, minimizing environmental impact and operating costs. Advanced PLC-based control units enable programmable wash sequences and real-time diagnostics for system monitoring. Capable of handling up to 60 cars per hour, this automated system provides consistent, time-efficient cleaning with minimal resource consumption. Widely deployed across service centers and metro car parks in Ahmedabad, it reflects a growing shift towards sustainable and technology-driven automotive maintenance. The global supertanker employs advanced aerial firefighting systems, capable of deploying large volumes of fire retardant or water with precision. Its drop system includes two primary modes, the 2-valve and 4-valve configurations. The 2-valve drop operates at standard pressure, releasing retardant in a controlled, targeted manner. This setup, enhanced with GoPro footage, provides visual verification and training data. The 4-valve configuration allows for low pressure, wide area coverage, ideal for suppressing surface fires or establishing containment lines. A notable example of its operational capability is the drop conducted, demonstrating the aircraft's efficiency in rapid response scenarios. With a maximum capacity of 19,200 gallons, the global supertanker's modular system enables adaptable flow rates, minimizing drift and optimizing ground impact during wildfire suppression missions. At a PET plastic recycling facility in eastern France, the process begins with the intake of compressed PET bottle bales from regional sorting centers. These bales are mechanically opened and fed into a conveyor system that initiates the recycling line. A magnetic separator removes ferrous contaminants, followed by a pre-wash stage to eliminate adhesives and surface residues. Optical and manual sorting stations then isolate non-PET materials, ensuring feedstock purity. The sorted PET undergoes size reduction via an industrial grinder, producing uniform flakes. These flakes pass through advanced sorting modules capable of detecting polymer type and color, removing any incompatible material. Clean PET flakes are conveyed into silos for drying before thermal extrusion. The molten PET is filtered, extruded into strands, and pelletized. The pellets are then subjected to a nitrogen-based decontamination phase, rendering them food contact compliant. This facility processes up to 4 million bottles daily, generating high-purity rPET pellets for closed-loop applications, such as new bottle manufacturing, aligning with EU sustainability directives and circular economy principles. Strategic Materials manages the largest glass recycling operation in the United States, focusing on efficient processing of mixed post-consumer glass known as 3-mix, which includes clear, green, and amber glass. The recycling process begins with pre-processing, where ferrous metals are removed using magnetic separators, followed by air classification to eliminate lightweight contaminants like plastics and paper. Drying equipment further prepares the material by reducing moisture content. Subsequently, the glass proceeds through optical sorting systems that identify and remove residual impurities, such as ceramics, stones, and heavy plastics. The cleaned glass is then sorted by color: flint, clear, amber, brown, and green, and stored as furnace-ready cullet. This high-purity cullet is supplied to manufacturers for reuse in container and specialty glass production. The process supports infinite recyclability of glass, substantially lowering energy requirements and emissions compared to producing new glass from raw materials. This closed-loop system enhances sustainability, reduces landfill waste, and conserves natural resources, making glass recycling both environmentally and economically beneficial. Hydrojetting a sewer manhole is a high-pressure cleaning process used to remove blockages, grease, debris, and sediment buildup within sewer lines. The technique employs specialized nozzles attached to a high-pressure water hose that directs a powerful water stream into the sewer pipes through the manhole access point. This effectively breaks down and flushes away obstructions, restoring optimal flow and preventing backups. The process is environmentally friendly, using only water without chemicals. Hydrojetting also cleans pipe walls thoroughly, reducing the risk of future clogs and corrosion. It is widely used in municipal and industrial sewer maintenance for efficient, non-invasive cleaning. At Laplace Equipment, pipe cleaning was conducted to remove residual concrete from a pumper truck using a high-pressure water jet system. The operation utilized 20,000 psi at a flow rate of 20 gallons per minute, delivering focused hydraulic force capable of breaking down and flushing out hardened material. The system's lance was inserted into the pipe, progressing steadily to ensure complete internal coverage and prevent damage. The cleaning process lasted precisely 11 minutes and 24 seconds, effectively restoring the pipe's internal diameter and ensuring optimal performance for future concrete pumping operations. This method ensures efficiency, safety, and minimal downtime. A plumber was deployed to clear a blocked stormwater grate following heavy rainfall. The obstruction, primarily composed of leaves, debris, and sediment, restricted water flow and caused localized flooding. Using a pry bar and suction equipment, the grate was lifted, and accumulated materials were manually removed and flushed using high-pressure water. The area was then inspected for underlying pipe blockage. This rapid intervention restored drainage functionality and prevented further water buildup in the affected zone. The Root Ranger double-ended nozzle was used to remove hardened cement paste from 8 inches cast iron pipes via high-pressure water jetting at 50 LPM and 4,000 psi using a 3/8 hose. Unlike high-speed rotating heads that tend to jam in cement slurry, the Root Ranger features a turbine-driven dual-ended design that excels in deep penetration and effective material removal. A 1/2 Warthog unit, 72 LPM at 4,000 psi, was initially deployed, with the slow front jet disrupting the cement while rear jets provided thrust and ejection. However, for deeper and more efficient cutting, the Root Ranger proved superior. Its front-facing jet blasts through thick deposits, while rear jets carried debris out, ensuring continuous cleaning. This configuration minimized water usage while maximizing effectiveness in clearing cemented lines.
Effective to get that end result we're looking for.
Sewer cleaning in Los Angeles, California with Kent Carlson involved the use of high-pressure jetting equipment to remove sediment, grease, and debris buildup within municipal sewer lines. The operation utilized a vacuum combination truck equipped with a high-pressure water jet up to 4,000 psi and debris tank. Jetting nozzles were inserted through manholes to scour pipe walls, while simultaneous suction extracted dislodged material. This method ensured full pipe restoration, minimized flow obstruction, and prevented future blockages. Safety protocols, including confined space entry procedures and gas monitoring, were strictly followed throughout the operation, ensuring compliance with municipal. Speed Shine Express Car Wash provides exceptional car cleaning and shine using state-of-the-art Belanger spin light equipment and a choreographed wash process. Upon arrival, you must perform car in neutral, wipers off, foot off brake, hands off stirring. Then the cleaning agent is automatically pumped to prepare each vehicle. The wash tunnel has 2 whisper wheel brushes, 2 quick-fire wraparound brushes, and a wave low/full side washer for a thorough exterior cleaning. High-quality Lustra foam and foamy Glow & Go products are dispensed near the wash stage using Hydro-X and Sudzer domes, creating a dense, effective foam that rinses easily, even with heavy application. A 12-nozzle drying system ensures that the vehicle is dry when exiting, while 2 duo scrubbers provide specialized wheel cleaning. The result is a clean, shiny, foam-free vehicle. Speed Shine's process not only improves the appearance of your vehicle, but also maintains operating efficiency and environmental control. The Eldon state-of-the-art tire recycling plant is engineered for precision material separation and consistent output quality across multiple fraction sizes. The process starts with the Eldon Super Chopper, which reduces whole tires into shreds. These are fed to the MPR 160T for chip production, and then to a steel cleaning system, yielding steel fractions with 96 to 98% purity. Material is conveyed to silos before entering the fine granulation stage using FG1504 granulators. Steel and textile contaminants are separated by the PC15T classifier, which also distributes in-feed to additional granulators. The PC15 and C26 separation table ensure optimal purity, producing rubber granules free from steel, textiles, stones, and non-ferrous metals. Output sizes range from 100 x 100 mm TDF chips to rubber granulate sized 0.5 to 2.0 mm or 2.0 to 8.0 mm. Capacity reaches 10 tons per hour for shreds or 5 tons per hour for high purity granules. Fraction changeovers are achieved by screen replacement. Veolia Water Network Services utilizes vacuum excavation as a non-destructive method for safely and accurately exposing underground utilities. This technique employs compressed air to loosen soil, which is then removed using a high-powered vacuum system and drop the excess soil into the empty space, minimizing the risk of damaging buried assets such as water mains, electrical conduits, or gas lines. Vacuum excavation is particularly effective in densely populated utility corridors, confined urban spaces, and high-risk excavation zones where conventional mechanical methods may pose hazards. The method supports utility location, inspection, maintenance, and connection works without disrupting existing services. Veolia ensures strict adherence to safety protocols, environmental regulations, and engineering standards throughout the process. By using vacuum excavation, Veolia improves operational efficiency, reduces reinstatement costs, and enhances the reliability of water and wastewater infrastructure while minimizing environmental and public impact during excavation activities. Watermaster Shallow Water Solutions uses the Amphibious Watermaster machine to mechanically remove invasive aquatic vegetation from shallow water bodies. Equipped with cutters, rakes, and clamshell buckets, it targets species such as water hyacinth, common reed, milfoil, and trash. This chemical-free method minimizes environmental impact by preserving native flora and fauna. Designed for variable water depths and soft substrates, it accesses hard-to-reach areas with precision. Removing excess biomass improves water flow, dissolved oxygen levels, and hydraulic performance. The system supports flood mitigation, habitat restoration, and water quality management. Watermaster solutions comply with technical and environmental standards, making them suitable for municipalities and environmental agencies managing invasive species in sensitive aquatic ecosystems. The Watermaster multi-purpose amphibious dredger is engineered for shallow water operations up to 6 meters in depth, including dredging, raking, and pile installation. Delivered fully assembled, it is immediately operational without additional setup and self-launches without crane assistance. The unit operates autonomously, free from cables or support vessels, enhancing operational flexibility. Featuring a wide working area and a 180 degrees turning radius within 110 square meters, the dredger achieves a dredging capacity of 500 to 900 cubic meters per hour. Applications include maintenance and deepening of shallow waterways, flood prevention, debris and invasive vegetation removal, as well as infrastructure and industrial water projects. The Watermaster is manufactured in Finland and supported globally with comprehensive training and readily available spare parts. Its modular design facilitates ease of maintenance, making it a reliable and versatile solution for diverse aquatic excavation and environmental management tasks. Wohlschläger Flachenreinigung specializes in technical surface and subsurface cleaning operations using an integrated process involving vacuum, pressure, and mechanical systems. The procedure begins with mechanical street sweeping to remove loose debris from road surfaces. For manholes and catch basins, suction units extract accumulated sludge and sediments, preventing blockages. In large surface areas, high-pressure water jets are deployed to dislodge adhered contaminants, followed by vacuum extraction. Sewer and drainage channels are cleaned using rotary jetting nozzles that break down deposits and flush out material with controlled high-pressure water. A critical part of the process is the precision drilling and flushing of infiltration pipes, where rotary drills are used to clear clogging and restore flow capacity. All extracted material is contained and transported for proper disposal. The entire workflow is executed with equipment designed for environmental compliance and minimal disruption, ensuring that streets, sewer systems, and infiltration networks remain functional, safe, and within regulatory performance standards. A blocked 100 mm 4 inches sewer pipe at a childcare center south of Brisbane was cleared after a significant obstruction of nappy wipes was found at the pipe's entry into a manhole. The blockage restricted flow and posed a sanitation risk. Technicians accessed the manhole and visually identified a dense mass of wipes lodged at the connection point. Due to the fibrous nature of the material and its resistance to water jetting alone, a mechanical retrieval method was employed. A specialized sewer hook tool was inserted through the manhole to physically break up and extract the blockage. The wipes were manually removed in sections until flow was visibly restored. Follow-up flushing and inspection ensured the pipe was completely cleared. These products do not break down like toilet paper and can accumulate quickly in sewer infrastructure. Residents and facility operators are urged to dispose of wipes in bins, not toilets, to prevent blockages, overflows, and costly repairs. Dredging by Esks Cleaning at Hermanus involves professional leaf vacuuming using high-capacity suction equipment to clear large volumes of leaves and organic debris from streets, pavements, and public spaces. The process improves safety, prevents blocked drains, and enhances the cleanliness of urban environments. At the Hermanus location, operators used mobile vacuum units with powerful fans and collection tanks, ensuring efficient removal without damaging surfaces. Collected material is transported for composting or green waste processing. Esks Cleaning adheres to municipal standards for environmental management and public hygiene, delivering reliable seasonal maintenance services across urban and landscaped areas. The Steel Maximo is a powerful triple weed brush machine with a working width of over 3 meters, designed for large surface areas. Its 3 brushes efficiently move weeds and debris to either side for easy pickup by a sweeper. The working width is adjustable via a double pivot on the brush arms, and brush rotation and position can be controlled from the cabin for versatile operation on surrounding roads for cleaning paths. The Watermaster MC3 is a versatile, self-propelled tricycle vacuum cleaner engineered for high-efficiency cleaning of festival grounds and large outdoor areas. Featuring a low soil pressure trike chassis, it provides excellent maneuverability and minimal turf damage. The machine is equipped with a wide front suction nozzle and a powerful motor delivering robust vacuum performance for rapid debris collection, including waste bags, boxes, and umbrellas. It incorporates a variable hydrostatic transmission for smooth speed control and operator comfort, along with a 10 cubic meters tipping hopper for quick unloading into containers. The MC3 offers excellent operator visibility from the cabin and supports multi-application use in agriculture, horticulture, and industrial sectors. The TRI LOTS-25 vacuum container is engineered for high-capacity collection of leaves and municipal waste. It integrates a high-efficiency impeller driven by an independent, Stage 5 compliant, water-cooled HATS diesel engine, ensuring low emissions and operational reliability. The impeller housing is equipped with a sound dampening package to minimize acoustic output during operation. Designed for intensive use, the impeller generates substantial suction power and is enclosed within a wear-resistant housing featuring a replaceable inner liner. This modular design facilitates maintenance and extends service life. The TS25 is optimized for performance in demanding environments, offering a robust and efficient solution for large-scale debris collection operations.